5.6, indirect proof and inequalities in two triangles. So the first problems want us to use the hinge theorem and its converse to complete the statements with less than, greater than, or equal to. So number 8, they give us two triangles. Both of them are right triangles. And we have two congruent sides. And so the 1 and 2 that are in here are just the names of the angles. And so the question is the measure of angle 1 blank the measure of angle 2. Is it equal, greater than, or less than? What? Yep. Going to be equal. Because we don't have any other information, so all we have to go off of is that they, well, actually, it wouldn't matter. They have to be equal because we don't have anything else to go off of. 10. All right, so this one, they give us two triangles that are touching, and so then the question is xy is equal to, greater than, or less than zy. And so before I can answer this, what else do I have to make note of? Because I only have one congruent side.
That wy or wy is equal to wy.
Yep, so those two, because of the reflexive property, that's also congruent, and so now I have two congruent sides. So then what can I say about xy compared to zy? Yep. So 41 is bigger than 38, so that means that xy has to be greater than zy. 12. Again, I've got two triangles that are touching. I have the 1 and the 2 are angle names. If they don't have the degree symbol, it's just the name of the angle. And then we have the side length of 11 and the side length of 13 there. So what else do I know about this triangle?
Is it congruent in the middle?
Yep, this middle part is congruent. There's no like letters on this one. So anyway, so reflexive property says that that has to be congruent as well. And so then the question is the measure of angle 1 blank the measure of angle 2. So is it greater than, less than, or equal to?
Less than.
Yep, so 11 is less than 13, so that means that this angle has to be less than the other one. $14. right, so this time we have, again, two triangles that are touching. They've given us the one side, so again, we can say that VT is congruent to VT. And so then the question is UT blank SV. So what's the connection between UT and SV?
UT is greater than SV.
Yep. Greater than, because 45 is bigger than 44. All right, questions about those ones?
Is that like,
What?
is that supposed to be V or U?
This is a V, this is a U, and this is a U, and this is V. This one look a little. There we go. All right, the next one say to use an inequality to describe a restriction on the value of x as determined by the hinge theorem or its converse. So up to this point, we've just been saying if it's greater than, less than, or whatever. But now they're going to give us values, and we're going to actually be solving for like possible like x values or whatever variable they give us that would make the statement true according to the hinge theorem or its converse. So 18. All right, so with a problem like this is a 9, not an A. I'm trying to figure out what possible values of x would work for this problem. So the first thing is I know I have to have two congruent sides for this to work. So 8 and 8 obviously are congruent, and then much like with many of the previous ones, we have this side that's touching, so that is also congruent. So that means I know that the hinge theorem applies. So if this angle is 60 and has a side length of 9, this angle is 70, what does this side length have to be? It's an inequality.
Has to be
It just has to be greater than 9. It could be 9.1. It could be 100. We don't know. It just has to be greater than 9. So all we would say that the answer is x is greater than 9. Um, 20. Same type of thing. So this angle, I'm drawing it in here, but it goes in this spot here. It's just kind of big to right there. All right, so I've got to use the hinge theorem and solve for x. So what do I know about these triangles? Do what? Yep, that's congruent. So then, based on that, if this side length is 4 and this one is 2, what do I know has to also be true?
4x minus 5 has to be greater than 65.
Less than?
Oh, less than.
4 is bigger than 2, so it has to be less than. So 4x minus 5 has to be less than 65. Again, because 4 is bigger than 2, so that means that this one is bigger. So that's the way the mouth is opening. So then this value is going to be less than that. And then we just solve it like a normal equation. So add 5. 4x is less than 70. Divide by 4. X is less than 17.5. So that would be the answer for that one. So we don't actually have to solve for the whole like angle. We don't have to like plug it back in and figure out what it's equal to, although we could do that. All they're asking us for is to just basically figure out what values of x would be like true for that. Questions on those ones? All right, in exercise 21 through 23, write the first statement for an indirect proof of the situation. So our first statement is essentially the opposite of what it's trying to prove. Essentially all we have to do on those ones. So 22, the statement is in triangle MNP, if Q is the midpoint of NP, then MQ is a median. So essentially when we're dealing with these, instead of saying like, when we're writing that first statement, instead of saying in triangle MNP, we're going to say given triangle MNP, where Q is the midpoint, so not like if, we're taking that out. So where Q is the midpoint of NP, and then the second part that's like the then blah, 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 that's the part that we're going to state the opposite of pretty much every time. So the first step of this indirect proof would be given triangle MNP, where Q is the midpoint of NP, assume, so notice I'm changing then to assume, MQ is not a median. And that's all you'd have to put on that, because that's just your first step there. Now I can tell you that that's the only part of an indirect proof I'm going to make you do. We're not actually going to be doing the indirect proofs. There's just other stuff that's more important that we need to cover than spending time on that. So, are there any questions about any of this?
So you just change it into like, instead of being if, it is, and then
Yeah.
just, like,
Pretty much given that this is the case, because that's really what your if is. It's like this is like the almost like the given part of your statement. And so then your then is what I'm trying to prove, you know. And so we just change it pretty much in every case to assume whatever that is. And then if it's something that's like a positive thing, then we're negating it. If it's something that's negated, then like if it was the opposite, you know, if MQ is not a median, or then MQ is not a median, then we would say, you know, then MQ is a median, or assume.
So we're only ever switching the last term?
Pretty much, yeah. Yeah. I mean, as long as it's written in this form, then yes.
Okay.
And pretty much all of them that are in here are. So, they're all very easy ones. All right, problems for this section, 7 through 15 odd, 19, 21, and 23. So you should have plenty of time to get this done in class. If you, for some reason, don't finish, then obviously it's Wednesday, it's not homework, but you do need to be working diligently, or I'm going to make you turn it in at the end of class if we're just goofing off the whole time. So, yes.
Can I do it?